All right, guys, let's do a few problems together off the 10-5 worksheet. This is a tough section right here, so let's work hard at this and see how we do. So in the first group of problems here, our directions are telling us to find the area of each regular polygon and to round our answers to the nearest tenth. So three-step process here. Step number one, let's come up with a formula here. Area of a regular polygon, just like in 10-3, is 1/2 times perimeter times apothem. But what makes this problem tougher than the ones that we saw in 10-3 are that this one is not going to give us a special right triangle the way that we got in 10-3 when we were dealing with triangles, squares, and hexagons. So trying to fill in what we know, 1/2, we do not know the perimeter of this figure, nor do we know the apothem. So we've got two things going on here. But the perimeter really isn't going to be that tough to figure out at all. They've given us 8 meters here for the length of one side. So I'm going to write here that side is equal to 8. And to find perimeter, we're going to take the length of each side, which is 8, and multiply it by the number of sides. Well, this is an octagon, looks like a stop sign. It's going to have 8 sides to it. So that means that our perimeter is 8 times 8. It's going to be 64 meters for the perimeter of this figure. So that really wasn't very tough to figure out here at all. But as far as coming up with the apothem, what makes these problems in 10-5 tougher is that they're going to require trigonometry. Okay. So in every one of these figures, we want to get used to this idea. Find the center, draw an apothem going straight down perpendicular to that side, and then draw a radius right there. And then we've got this little piece here on the bottom, and there's our right triangle. Now, the one thing that we know right now in that red triangle, if each side of this figure has a length of 8 meters, this little piece in red down here, which I normally call x, is going to be half of that. That's going to be 4 meters in this case. And the other really important thing to figure here is what kind of angles are we dealing with. So theta, which is our central angle, is always found by taking 360 divided by the number of sides, which in this case is 8. And 360 divided by 8 is 45 degrees. But the angle that we're interested in, this one right there inside that triangle, is always going to be half of a central angle. So if I take 45 and divide it by 2, I get 22.5 degrees for the measure of this angle right here. So let me write that up here, 22.5 degrees. And what we need to know here, everybody, is the length of our apothem. That's what's missing. That's what's going to go right here. And the apothem is this piece right here. So within that red triangle, we now know the measure of this angle, 22.5 degrees. We know that 4, which is our opposite leg, it's across the triangle from us right there. So we have the opposite leg, and we're looking for A, which is the adjacent leg. So think about which trig ratio uses opposite leg and adjacent leg. That's going to be tangent. So we're going to write the tangent of our angle, 22.5 degrees, is equal to the opposite leg, 4, over the adjacent leg, which is A. Not our favorite setup because the variable's on the bottom of the fraction, but we know how to handle that by now. We just flip-flop the left side and the bottom right. And we're going to get A is equal to 4 divided by the tangent of 22.5 degrees. And that is something we can just type into our calculator. And let's see what we get here. 4 divided by the tangent of 22.5 is going to get us an answer of 9.66. So let's write that down here for apothem, 9.66. It's not exact, but it's as close as we can get here. So we're going to write that down, 9.66. And now we know the length of both our perimeter and our apothem. So we're ready to move on to step 3, which is to solve this thing. Really, we're just evaluating the right side. So 1/2 times 64 times that apothem we just came up with, 0.5, times a perimeter of 64 times, and the best thing I could do here is hit my last answer button to get an area here of 309.019, and I believe the directions said round to the nearest tenth. So that is going to be 309.0, and you do need to include the 0.0 there. All right, so 309.0. Units were given to us in meters, so area units are going to be square meters. Ooh, we'll cram that in there. Okay, and there's your answer to problem number 1, 309.0 square meters. Okay, tough problem. Let's take a look at these ones. In these problems here, they kind of gave you quasi little word problems right here. It's really the same setup that we were dealing with before, but let's see how much we can figure out without looking at a diagram. So we're trying to find the area of a regular pentagon with a side length of 10. So let's just keep going. And we could draw this pentagon, but I'd like to see if we can avoid it. Let's take a look. I don't know. Area of a regular polygon is 1/2 times perimeter times apothem. Step 2, fill in what we know. Area is 1/2. We do not know our perimeter. We do not know our apothem. So we've got two things that we've got to figure out here. Well, one of them is going to be easier than the other. Let's take a look. They're telling us here that our side length is 10. So our side length, there we go, is 10. If we want to find perimeter, you simply take the length of each side, which is 10, and multiply it by the number of sides. And hopefully we know this. In a pentagon, your number of sides is 5. So 10 times 5 is going to get us 50 for the perimeter. And we were able to do that without a diagram, so that wasn't too bad. But we also now need to come up with the apothem, and that's going to be a little bit tougher. Now, what I'm going to do, I'm not sure if this is something you guys would feel comfortable trying on your own, but what I'm going to do here is draw not the entire pentagon, but just the triangle that we normally create by drawing an apothem, a radius out here to the side, and then this little piece here on the bottom with a right angle there is what we normally call x. Now that x, if you remember, is half the length of a side within this figure here. So knowing, as we know, right up here, that our side length is 10, we can actually figure out the measure of x pretty quickly by just taking 10 for a side length and dividing it by 2. We know that this piece right here is going to be 5. The other important thing we have to do is to figure out the measure of this angle right here. And to do that, we've done this work a few times before. Let's find theta. Theta is 360 degrees divided by the total number of sides we're dealing with. And again, in a pentagon, the number of sides is 5. 360 divided by 5 is 72 degrees for our central angle. But for our angle right here, we always take a central angle. We always take a central angle. Let me write that a little smaller and divide it by 2. 72 divided by 2 means that the angle we're dealing with right here is 36 degrees. And now from here, we're going to be able to figure out the length of our apothem by using some basic trig. So from the 36 degree angle, remember you're standing right here, 5 is your opposite leg, A, the apothem, is your adjacent leg. This is again a tangent problem. So the tangent of 36 degrees is equal to the opposite leg of 5 over the adjacent leg of A. Again, variable on the bottom of the fraction, so we just flip these two spots around here and get A equals 5 divided by the tangent of 36 degrees. And we can type that into our calculator, 5 divided by tangent 36, and let's see what we get. 5 divided by tangent 36 is equal to 6.88 is what I'm going to write down here, 6.88. And that is the length of the apothem that we needed. 6.88. And now we know our perimeter, we know our apothem, so now I think we're ready to put all this into the calculator and figure out the answer here. 1/2 times 50 times that 6.88. So 0.5 times a perimeter of 50, we said, times our apothem, the 6.88, which isn't quite exactly perfect yet, so I'll hit answer, and that'll get me a more accurate answer of 172 0.0, because I think they wanted things rounded to the nearest tenth. So 172.0. Side length was given to us here in inches, so area is going to be square inches there. So 172.0 is going to be our answer here for problem number 5. If you need to draw the figure out, go right ahead. Hopefully you can work your way around it. And I keep forgetting to do problems like number 12 in your notes here, guys. So I hope you're watching this video, otherwise you're going to be very confused. In every problem we've been doing here, we've been using this formula. Area of a regular polygon is 1/2 times perimeter times apothem. Except it doesn't work here. This is not a regular polygon. The sides are not congruent, and for a triangle to be regular, all the angles would have to be 60 degrees. So there's a formula here that I haven't told you guys yet. And what this is an alternate formula for area of a triangle. You guys know that area of a triangle is 1/2 times base times height. That doesn't really help us in this setup right now. There's another formula for it that I haven't taught you guys, and here it goes. It is 1/2. There's 3 different ways of writing this formula, but I kind of like it this way the best. 1/2 times little a times little b multiplied by the sine of angle C. Now that is a trigonometric formula here for area of a triangle, and it actually does relate to the 1/2 times base times height, but I don't think we need to get into that right now. The important thing here is that little a and little b are 2 side lengths within a triangle, and angle C is the angle in between those two. Let me show you what I mean here. If I were to say that this 6-meter side is little a, that means that angle A is opposite from it. It's across the triangle. So this would be angle A, and the 6 would be side A. If the 4 meters right here, if we call that one side B, then across the 4 meters, this side over here would have to be angle B. So by process of elimination, that's angle A, angle B. This angle right up here would have to be angle C. So when we talk about this formula right here, we are using 2 side lengths, little a and little b, and then the measure of the included angle between them, and that would be the angle C here. So it's a pretty cool formula. It allows you to find area of a triangle if you know 2 sides and the included angle. So here we go, 1/2. One of the sides we know, side A, I called it, is 6. Side B is 4, although if you flip those two, it wouldn't matter at all. And we multiply that by the sine of the angle located in between them. Well, in between the 6 and the 4 is a 68-degree angle. And that's it. Okay, so really, that was step 1, write your formula. Step 2, fill in what we know. And step 3, let's just put that entire right side into our calculator at once. Okay, 1/2 64 sine 68. Okay, so let's try this again here. So we've got a 0.5 multiplied by 6, multiplied by 4, multiplied by the sine of a 68-degree angle. Let me make sure I did that right. So 1/2 times 6 times 4 times the sine of 68 gets us an area here of 11.126. If the direction still said nearest tenth, that would be 11.1. So we'll write that down. So 11.1 units were given to us in meters, so that's going to be square meters now for number 3. All right, guys, that is a decent jump here on the 10.5 homework. Let's give those a shot, and let's see how you do on those.